So we've been working with inequalities and equations and graphing them and manipulating them, but why are we doing that? What is the whole purpose of what we're doing? So where do these equations actually even come from? Real world problems. We're about to get into our project and it's all about real world problems. Math doesn't make any sense unless it's in some sort of context. So we're going to take a look at some problems, some word problems, and try to pull out the equations from the problems. Here's the first problem. Pause the video to take a minute and write this down on your paper. The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended? So when you're first jumping into the problem, you want to ask yourself, how many unknowns are in the problem? Or what is the problem actually asking? And the answer is how many children and how many adults. So we have two unknowns. So we want to give these unknowns variables. So if we are talking about the number of adults, we would have that the number of adults is our letter A. Pretty appropriate, adults A. Okay, then we have the number of children. Let's name that C. So now we have two unknowns, two variables. Then we want to go ahead and categorize. We want to look through the problem and categorize what different issues or what different topics are being talked about in the problem. So if we read through the problem, in the second sentence it says, on a certain day, 2,200 people enter the fair and $5,050 is collected. So we know that we're talking about two different issues. We're talking about total number of people and money. So we got people and money, number of people and money. So we're going to have two different equations pulled out of this one problem. Okay, so we've got two different variables, A and C, and now we're going to have two different equations. So we're going to have, if we look at the total number, okay, clearly children and adults, those are the only two categories, right? We're not having pigs come in or cows come in. We're having people come in. And we've got adults and children. So we look and we can have that, you know that total number of adults plus total number of children, that's the total amount of people, right, is going to be 2,200 total. From this right here, this tells us 2,200 people, 2,200 is our total. Then we're going to have our other equation when we're talking about money, right? So we have total number of adults, and adults cost how much? They cost $4 per person, okay? So if we have $4 per adult, then we'll have for our total income, we have 4A, because $4 per adult. So say we have one adult come, you only make $4, right? Two adults, 4 times 2 is 8. So that's where that comes from. And then we have a certain price for children too. So we will take $1.50, so plus $1.50 or 1.5 times C. So if we had one child come in, we'd only make $1.50. If we have two children, you'd have 1.5 times 2, which gives you 3, correct? And our total income is $5,050. And this is as far as we're going to go for now. We're not actually going to solve the problem because later on in the week we're going to come back to this problem and solve it. But all I want to do right now is just be able to pull out the important information, all these important pieces, and write the equations that we need. Okay, so you're going to want to keep your notes from today because we're going to come back to it and actually solve these problems later. Let's practice another problem. Pause the video and write this down in your notes. A volleyball team placed 2 orders with a merchandise company. The first order was for 13 t-shirts and 4 volleyballs and totaled $487. The second order was for 6 t-shirts and 2 volleyballs and totaled $232. The bills do not list the per item price. What were the costs of 1 t-shirt and 1 volleyball? So again, the first question we want to ask ourselves is how many unknowns are in the problem, or what is the problem asking? So let's take a look at typically it's going to be in the last question, the last sentence of the problem, and the last sentence says, what were the costs of 1 t-shirt and 1 volleyball? So we've got our 2 unknowns right there. We've got what are the costs of 1 t-shirt, right, and costs of 1 volleyball. So now we can give our unknowns a variable. So if we're talking about the cost of 1 t-shirt, so we have the cost of a t-shirt, and let's go ahead and give that the variable t. It's a funny looking t, but it's all right. And then we have the cost of a volleyball. Beautiful. And we could give that a v. Cool? All right, so now we have our 2 unknowns. Since we have 2 unknowns, we need 2 equations in the problem. So we need to figure out what are 2 different issues, or what are the 2 different topics being talked about in the problem. And there are 2 things laid out for us. We have the first order and the second order, right? So for the first order, we can write, so first order, let's go ahead and make an equation for that. So if we have 13 t-shirts, so 13 t for t-shirts for the cost of the t-shirt, and plus 4 volleyballs, so 4 volleyballs times the cost of the volleyball gives us a total of $487, right? So we have 13 times t plus 4v equals 487. That gives us the total amount. Then we have a second order, this second order right here, okay? So that was, if we write second order, all right, then we have 6 t-shirts, so 6t plus 2 times the cost of volleyballs totals $232. Okay, so this just sets up our problem. We're not going to solve this problem, but keep this problem in your notes. We're going to come back to it. So we have here that our cost of t-shirts is T, cost of volleyball is V. Our 2 issues that we're talking about, or our 2 topics that we're talking about, is a first order and the second order that we put in. Okay, so we have our first order and we have our second order. You use the information for the first order, clearly, that's in the sentence, to make the equation. Then you use the information in the second order sentence for the second equation. It's beautiful. It works well. Again, keep this in your notes. We're going to come back and actually solve this problem later on in the week. Now your task is to go back through what you just wrote and read through the problems and read through the solution, or, well, the setting up part of the solution, and identify what you don't understand still, because we're going to go over everything tomorrow. And so put a star next to a question mark, write some questions, have questions ready for specific things that you don't understand from this video. If you need to re-watch the video, please do that again. You always catch something a second time, a third time that you didn't catch the first time.